Hi friends, I'm Yakuta Karkhanawala. Today we'll start with the next chapter of C, that is dynamic memory allocation. It's one of the very important topic available in C, that is dynamic memory allocation. So we have normally two types of memory allocation. One is static memory allocation and another is dynamic memory allocation. Let's understand the difference between static and dynamic memory allocation first. Okay, so static memory allocation means if when we allocate memory during compile time, then it is known as static memory allocation. That is when we are compiling the program, and that time the memory gets allocated for a variable, and it is known as a static memory allocation. While in case of dynamic memory allocation, the memory is allocated at the runtime. That is, the compilation process is already done and we are executing the program. At that time, when we allocate the memory, then it is known as dynamic memory allocation. Static memory allocation should be used when you are very well aware that how much memory you will require for this particular program. So for example, if you want to store the data of 100 students and you know that more than 100 students data you are not going to store, or then in that case you go for static memory allocation. While in case of dynamic memory allocation, when you use this, that is when you do not know what would be the required amount of memory that will be required for a particular program. When you are not sure that how much memory you will require for this particular program, and at that time you go for dynamic memory allocation. In general, normally we do not know what would be the memory required for a particular program or a storage. Then it's required to go for dynamic memory allocation. What is the disadvantage of static memory allocation? That it wastes memory. That is, suppose if you allocate memory for 100 students and only 50 students data you are storing, that means that the rest of the 50 students data gets wastage. So in static memory allocation, wastage of memory is high, while in case of dynamic memory allocation, there is no wastage of memory. That is, whatever memory you required during runtime, you decide it and accordingly allocate the memory. The advantage of static memory is that it has faster speed of execution, while dynamic is slower in operation. When we were using static memory allocation, that is when we use arrays, means arrays was an example of a static memory allocation. When I write integer a10, means in the program itself I am fixing that the array size is equal to 10, means I can store maximum 10 values inside this array. If I store only 2 values, means the remaining 8 values memory gets wastage here. Okay, so this was array was an example of a static memory allocation. Well, in case of dynamic memory allocation, we have to compulsory use pointers. Okay, you can use an integer pointer, float pointer, or so on. And for that, we have number of different functions like ManLock. We'll understand the syntax later on in the coming slides. Okay, how to allocate dynamic memory allocations using pointers. So this is the difference between a static and a dynamic memory allocation. Let's start with dynamic memory allocation, that is allocating memory during runtime. For dynamic memory allocation, we have 4 library functions. These are Malloc, memory allocation, Kellogg, that is contiguous memory allocation, RealLog, that is reallocation, and freeing of the memory. Okay, these are the 4 important functions for dynamic memory allocation. Make sure that in all your DMA programs you use free function compulsory at the end of the program. Also, whenever you are using this DMA functions, then compulsory include stdlib.h header file. So we'll start with the first dynamic memory allocation function, that is malloc. Malloc stands for memory allocation. This malloc function is used to reserve the block of memory for a specified number of bytes. Means if you want to allocate the memory for some specific number of bytes, you use malloc functions. This malloc function is going to return a void pointer. Whenever you use malloc function, it is compulsory to cast the pointers to any of the other data types, like converting the void pointer into an integer pointer or a float pointer or a character pointer. Whenever you allocate memory using malloc functions, there would be garbage values in that particular allocated space. Okay, so you will have some values in that space, memory space reserved, but all those values would be initially considered as garbage value. So how you are going to use malloc function? Malloc, inside bracket you give the size, that is how much bytes you want to reserve during runtime. So if that is your size. As I said, this malloc is returning a void pointer, you want need to convert it into some another data type pointer. So for that, casting is required. So in bracket before the malloc function, you write down the cast type star. Means it can be integer star or it can be float star and so on. It means that I am allocating the memory of this size, and at that particular memory location either an integer value or a float value or a character value will be stored. This malloc is going to return the address of the first memory location that has been allocated, and that address I'm storing it in a pointer PTR. So the address of the first allocated memory has to be stored in a pointer. Let's see the example of using malloc. I have a float pointer. Now I'm using malloc. Inside bracket I'm giving size as 100 multiplied by size of float. It means 100 multiplied by size of float is 4. So 400 bytes of memory is been reserved. And this malloc is been casted to a float pointer. Means at this particular memory, 400 bytes of memory, I'm going to store float values. And the starting address, the first address of the allocated memory is stored in PTR. Okay, so pointer holds address of the first byte in the allocated memory. If we do not get this 400 bytes of memory, then the malloc will return a null pointer if the memory is not been allocated. So let's see one program where we are going to use malloc function. I'm going to include two files, stdr.h and stdlib.h. Now inside main, I'm declaring an integer pointer. Now use malloc for allocating the memory. So malloc bracket, what would be the size? Size of integer means size of integer is 2, so 2 bytes of memory would be reserved. This malloc function, whatever memory is been reserved, that is been converted into an integer pointer. As I said, that void pointer has to be converted into some another data type pointer. Okay, so I'm converting it into an integer pointer. Means at this 2-byte location I can store an integer value, and the address of this particular reserved memory will be stored in the pointer P. So this is the declaration of the P, and this is known as the initialization of P using malloc, or you can say using dynamic memory allocation. Previously we were using P equal to ampersand of A or ampersand of B. We were giving the address of another variable inside P, but that was a static memory allocation. This is runtime memory allocation using malloc. At this particular memory location, I want to store some values. So I'll use scanf %d, and inside here I'll pass on the address. So I'm passing the address using P. Whatever memory has been reserved, that address is stored in P, and that P I'm writing in my scanf function. If I want to display the value which is being stored at this address, I'll use star P operation. So in the previous program we have seen, we have written integer star malloc size of integer, means we were reserving 2 bytes of memory using malloc. The other way of writing this is, you can also write it like this way: P is equal to integer star, that is casting malloc, and when we write 10 multiplied by size of integer, means 10 into size of integer is 2, so 20 bytes of memory would be reserved, and in this 20 bytes you can store 10 integer values. Or else you can make it more generalized. Instead of writing 10, you can take the value inside n. So whatever value, that is how much memory you want to allocate for a program. So take the value of n, and inside malloc you can write it down n star size of integer. So if the value of n is equal to 10, then 20 bytes would be reserved. If the value of n is 20, means 40 bytes would be reserved. So you can use any of the three forms, and the last form is the most generalized form for using malloc, which has been it's been suggested that you go for this to have a complete dynamic approach in your program. Next is the Kellogg function. We have seen the malloc function, that was of memory allocation. Now we'll see the Kellogg function. Kellogg stands for contiguous memory location. Means the memory that has been allocated is continuous. Either you can go for malloc or you go for Kellogg. In case of malloc, whatever memory you allocate, that particular memory has garbage values. But in case of Kellogg, whatever memory you allocate using Kellogg, that particular memory will be initialized with 0 value. What is the syntax of Kellogg? So write down Kellogg. In bracket, you have to give two arguments: the number of blocks, and the second one is the size of each block. So n is the number of block, and size means the size of each and every n block. You have to convert it into cast type pointer, that is the void pointer has to be converted into integer, float and something, and the address of the memory that has been allocated in using Kellogg is been stored in a pointer. Let's see one example of using Kellogg. When I write Kellogg bracket 25 comma size of float, it means I'm allocating 25 different blocks, contiguous block, and each block would be of float size, that is 4 bytes. And this memory allocated is converted into float pointer. It means that at this particular memory allocation, I'll be storing the float value and the address of the first location I'm storing in pointer. So ATR should be a float pointer. Let's see one program of Kellogg. Say for example, I have a structure student. Inside that I have two members. One is roll number and another is A, array A. The size of array is 10. Then I am declaring a pointer to a structure that is P. So Kellogg is very much used with structure. Now I want to input the number of blocks. So, and this number of blocks value is been stored in the variable n. So scanf n. Now use the Kellogg function. N means the number of blocks you want. It means the number of students data you require, and each block would be of size of structure student. So each block would be of 2 bytes for roll number and 10 bytes of this array. That is okay. So that is 10 plus 2, that is 12 bytes. So the size of structure student would be of 12 bytes, and how many blocks would be reserved is n number of blocks. So n blocks and each block of 12 bytes. Converted into the structure pointer, structure student pointer, and the address is been starting address has been stored in P. Now I want to enter the values of roll number and A using this particular pointer. So I'll take a for loop for I equal to 0, I less than n, I plus means for n number of students data I'm taking a loop. Enter the roll number and name, scanf. So P is a structure pointer, so I'll use arrow, P arrow roll number, M, and P arrow A, that is my name, which is of percentage S. The control string for A would be percentage S because it's an character array where I'm going to store the name of the student in A. So this first the data of first student. Now increment P++. When you will increment P++ means the pointer would go to the next block, and for next block you enter the roll number and name and go on up till n times. So for n number of students we are entering the value of roll number and A. I'll continue with the program here. If I want to display the values of roll number and name of each and every students, then what I'll do is first is take the pointer back to the first location of the memory allocated. So for that, what I have to do is I'll use the subtraction operator, that is P minus equal to n. So, or you can write down P equal to P minus n, means taking the pointer back to the first location of the allocated memory. Again, take a for loop, use the printf statements, P arrow roll number, P arrow A for displaying the values of roll number and name, and increment the pointer for going to the next block. Do this for n number of times. After displaying the values of the structure variables, what we need to do is you need to compulsory free the memory. So how you are going to do the free the memory? Free bracket, write down the name of the memory that has been allocated is pointed by P. So write down free bracket P. So that memory would be released. When you execute the program, you'll get this output. Enter n means the value of n is right now 2 for simplicity. Enter the roll number and name. So this is for first block data where the roll number is 1 and the name is XYZ. Then P is incremented. So this is the second block data where the roll number is 2 and the name is ABC. And when I write P minus equal to A means the pointer goes again back to the first block, and afterwards when I display it I'll get the values at 1 XYZ and 2 AB. So this was about Kellogg functions. So we have seen how to allocate memory using ManLock and Kellogg within simple example. As I said, whenever you use ManLock and Kellogg, always go for use free function. This free function is used to free the memory that has been allocated using Malloc and Kellogg. What is the syntax of free? Is free in bracket you need to give the pointer. It can be an integer, float or character pointer. This statement when we write free bracket pointer means it frees the space which has been allocated by the pointer. Next is the last function of dynamic memory allocation is RealLog. Reallocation is used when you want to change the memory size of the already allocated memory. That is, the memory allocated may be insufficient or it can be more than required. So if you want to decrease the memory that has been allocated or if you want to increase the size of the memory allocated, you go for RealLog. So RealLog is used to change the size of the previously allocated memory. What is the syntax of RealLog? RealLog in bracket, you write down, give the name of the pointer where it is pointing to some particular memory address, whose memory you want to reallocate or whose memory size you want to change. Comma X means the new size of this particular memory allocation that has been pointed by PTR. Whatever new memory that has been allocated, the starting address is again stored in PTR. Means you overwrite it. If you want, you can store it in some another pointer also. So pointer is reallocated with a new size X. So realloc is used whenever you use malloc and Kellogg function, and if the space is insufficient, then it is going to return a null pointer. So what you can do is, if null has been written, then you can use realloc for allocating the memory again. So let's understand realloc using a simple example. I have an integer pointer ptr. First, I am allocating the memory using malloc. What is the size of the memory that has been allocated is 5 multiplied by size of integer, means size of integer is 2. So 5 multiplied by 2 is 10. This is 10 bytes of memory has been allocated using malloc. And the address has been pointed to by ptr. Now if I want to increase the size from 10 bytes to 20 bytes, then what I'll do is I'll use realloc bracket, pass the pointer and give the new size. So the new size would be 10 into size of integer. So 10 multiplied by 2, which is 20 bytes. Means instead of 10 bytes, I'm increasing the size of the memory allocation to 20 bytes. But if you want to decrease the size of this particular memory to 6 bytes, that is from 10 bytes, I want to bring it down to 6 bytes. Then what we'll do is we'll use realloc pointer bracket. Either you can write as 6, or what you can do is you can write down 3 multiplied by size of integer, that is 3 into 2, which will be 6 bytes of memory. Okay, so you can use realloc to increase or decrease the size of the previously allocated memory. Okay, let's understand realloc with a small program. First, include the file stdio.h and stdlib.h because we are going to use DMA functions. Inside the main, I am declaring two pointer variables. One is C and another is C1. Both are character pointers, means I am going to store some name inside this particular pointers. For allocating memory, I am using malloc function. Inside the bracket, I have written 10, means 10 bytes of memory would be allocated, and it's typecasted to character pointer. The first address of this memory allocation is stored in pointer C. Pointer has been declared, the memory has been allocated. I will store some value inside this particular memory allocate. For that, to use scanf. So scanf %s, since we are going to input a string, comma C. If you want to display the value of this, then use printf statement. %malloc 10 is the string that would be displayed, plus the value if I want to display, then %s, comma C. Now next is I want to change the amount of memory that has been allocated using malloc. Initially it was of 10 bytes. I want to increase the memory size to 20 in the same program itself. So what I'm doing is I'm using the realloc function. Realloc bracket, whose memory I want to reallocate is that of pointer C. So write down the first argument to realloc as C, comma, the new size of the memory allocation that you want. So the new size is 20. It means that instead of 10 bytes, now C will change to 20 bytes of memory. Whatever is the starting address of this 20 bytes of memory, that has been stored in C1, another new point. So now my new memory size has been allocated, which is of 20 bytes. I want to input some value inside this. So use scanf again. Scanf %s, comma C1. The value would be stored in this particular C1, and if you want to display it, simply use printf statement. Once you do this, this would be the output. Enter the string of size 10 because of the first printf statement. Since I've done scanf %sc, comma C, so first I'm entering a string which will have maximum of 10 characters, that is LJ college I've entered in C. Now using printf, this particular data would be displayed, whatever is been stored in C. So malloc 10 LJ college is displayed onto the screen. Now this memory 10 size has been changed to 20 using realloc function. So now for the next scanf function, enter the string of size 20. I am entering a big string which has more number of characters, that is LJ engineering, and it has been displayed onto the screen using the last printf statement, that is printf realloc 20 LJ engineering. Okay, so that's all for today. So this was all about the different dynamic memory allocations functions that today we have studied Malloc, Kellogg, RealLog and free. So that's all for today. Goodbye. Thank you.